So today we are going to discuss topic of synapse, presynaptic event, postsynaptic inhibition. All those things will be discussed today and tomorrow. So how many types of synapse do you know? Types of synapse. As we all know, and it was also asked in one of the examination in AIIMS, you should remember that. What are the differences between electrical synapse and chemical synapse? Okay, so first is electrical synapse. What is electrical synapse? And second is called as chemical synapse. So what is difference between electrical synapse and chemical synapse? Yes, anyone? What are the differences? You can comment in the comment section, chat section, so we can discuss it. Electrical synapse are mainly because of gap junction. They are mainly because of gap junction. Okay, and chemical synapse are having presynaptic vesicle. So the first difference which was answered in that particular question was that gap junction is the constituent of, yes, good morning Ravi, electrical synapse, and presynaptic vesicle is the constituent of chemical synapse. Second point, in electrical synapse there are ion current. They are current of ion. In electrical synapse there are ion current. Okay, and in this chemical synapse there is chemical transmission. There is chemical transmission. Point number 2. Point number 3, can you tell me in which synapse there is cytoplasmic continuity? Because these all were options in that particular question. In which synapse there is cytoplasmic continuity? Yes. In which synapse there is cytoplasmic continuity? So what do you think? Yes, cytoplasmic continuity. Cytoplasmic continuity is present in electrical synapse and absent in chemical synapse because of gap junction. And which synapse is bidirectional and which is unidirectional? Which synapse is bidirectional and which is unidirectional? If you see, your electrical synapse is bidirectional. Because of gap junction, it can go either way. So it is bidirectional. Yes, Ravi. And your chemical synapse is always unidirectional. Always unidirectional. Point 5. Which has synaptic delay, which takes some time to transmit. Synaptic delay is present in. There is no synaptic delay in electrical synapse, and there is synaptic delay of 1 to 5 millisecond in case of chemical synapse. Now, so these are two types of synapse. Now first about synaptic transmission, the chemical one, gap junction we have already studied. So this is your, as you know, this is your neuron, this is your neuromuscular junction. You all know this story before also, and you know that this is synaptic vesicle. In the neuron there are action potential coming out, and when there is action potential, it causes it causes opening of voltage gated calcium channel, and calcium will cause release of neurotransmitter. So this process is called as docking. The release of neurotransmitter with the help of calcium is called as docking phenomena. So what is the exact mechanism of docking? What is dock? At the seashore, when ships come and entangle like this by the chain, it is called as docking. Similarly, these synaptic vesicles are behaving like a ship, and it has to be deloaded. It is in the sea. It has to be deloaded, and for this there is a phenomena called as docking. So question can come in your examination regarding docking. So you should know exactly what is the mechanism. Okay, so it occurs at the junction of nerve terminal and synaptic vesicle. Suppose this is your synaptic vesicle and this is your nerve terminal. Okay, now between this there is a protein called as, there is a protein at the synaptic vesicle. This is your synaptic vesicle protein, so it is called as vesicle AMP protein. It is called as VAM protein or V snare. It is also called as V snare. Okay, and then it is bind with the, this is protein of the nerve terminal. This is your nerve terminal. Okay, so this is syntaxin. This is your syntaxin. Okay, or snap 25. Snap 25. And this occur with the help of a protein called as RUB3A, and also GTP needed. GTP is needed. So there is entanglement of the VAM with this protein called as syntaxin or snap, and then there is a protein called as neurexin. These all are docking proteins. Okay, and then there is a protein which is required for docking called as synaptogrammin. It is called as synaptogrammin. Who will tell me what is the role of synaptogrammin? Yes, Ravi. What is the role of synaptogrammin? Sagar, Samant. What is the role of synaptogrammin? Who will tell me? During docking, when voltage gated calcium channel open, what is the role of synaptogrammin? Yes, you can write in the chat box. Neuromarker, okay, it can be neuromarker, but in this docking, these all protein can be neuromarker, but in this docking protein, what is role of synaptogrammin? Yes, Sagar, one last chance. Ravi, Roshan. Yes, you should know that it is sensor of calcium. It is sensor of how many calcium? 4 calcium needed. 4 calcium needed. So role is it acts as calcium sensor. It acts as calcium sensor. Okay. Okay, so this is acting as a calcium sensor, and how many calcium needed? 4. 4 calcium are needed. Okay, is this clear or no? Okay, so this is basically docking which required synaptogrammin, V snare protein, and in the nerve terminal there is syntaxin. There is syntaxin in which synaptogrammin is acting only as a calcium sensor. It was one of the question in PG examination that in the docking proteins among all those which is acting as a calcium sensor, because when voltage gated calcium channel open, it got attached to the which protein? it got attached with the synaptogramine, and then there's a docking phenomena which cause release of neurotransmitter. Okay, now what are the post synaptic event? What are the post synaptic event? Who will tell me? What is EPSP? What is IPSP? Post synaptic events are of two types. It can cause EPSP or IPSP. What is exactly this? It is action potential or local potential. EPSP and IPSP are excitatory, this is inhibitory. So these are local potential or action potential. Who will tell me? These both are local potential or action potential. Is there any answer? Yes, very good. These two are local potential. So what do you think? Can they obey all or none or not? Yes, local potential or graded potential. So they obey all or none or not? Can they obey all or none law or not? No. So they don't obey all or none law. Summation is possible or not? Summation is possible or not? Yes, summation is possible. Summation, because they are local potential. They are graded potential, so they don't follow all or none law. But summation is possible. Now EPSP is actually excitatory postsynaptic potential. It is actually excitatory post synaptic, yes, potential, and this is inhibitory post synaptic. It is inhibitory post synaptic potential. Now this will cause what? If it is causing excitation, suppose if you are four person who are going to study group study, if you are going to have group study, and if you start gossiping about all those things about coronavirus, about Bollywood, and you don't study, then what is that? EPSP or IPSP? Is that EPSP or IPSP? It causes action potential or hyperpolarization? Yes, Anuj, you want docking? Okay, at the end I will explain. Okay, so, Anuj Kumar Baghel, Anuj Baghel, I will discuss this again after this topic. So yes, that is IPSP, not EPSP. Okay, Chetan Kumar, if something you add and it causes hyperpolarization, and it causes hyperpolarization. Okay, it is called as inhibitory post potential. It does not cause action potential. It does not cause action potential. The necessary thing will not happen because it causes hyperpolarization. And when you got summated together and it causes excitatory post synaptic potential, it is called as EPSP. It is called as EPSP, and this causes depolarization. This causes depolarization, and this can cause action. This can cause action potential. So EPSP can cause depolarization, IPSP can cause hyperpolarization. It causes action potential. It does not causes action potential. Remember that. If you are combining, if you are summating to cause depolarization, it is called as EPSP. And if you summate together to cause hyperpolarization, it is IPSP. Now EPSP is mainly because of what? It is mainly because of cation influx. It is mainly because of cation influx, like sodium, calcium influx. Of course, cation influx will cause EPSP, and IPSP is mainly because of influx, either anion influx or cation outflux or cation efflux. Is this okay or not? Can you understand this or not? Because in PGI, you will see so many questions. They will ask you which is causing EPSP, which is causing IPSP. So don't get confused. Whenever cation is going inside, it can cause depolarization, it can cause action potential. When anion is going out inside or cation is going outside, it can cause hyperpolarization. Is this concept clear or not? Yes or no? Because we are discussing about the post synaptic summation, then we will discuss about the post synaptic inhibition. Okay, now what is post synaptic inhibition or pre-synaptic inhibition? Can be of two type. Inhibition can be of two type. Post one is called as post synaptic inhibition, other is called as presynaptic inhibition. Can you tell me any example of presynaptic inhibition? One is post synaptic inhibition, other is presynaptic inhibition. Yes, if something, suppose this is A, okay, and it is inhibiting the B, it is post synaptic inhibition by causing IPSP, presynaptic is like this. This is A, it causes EPSP, but it can be inhibited presynaptically like this. It can cause IPSP. So it is called as presynaptic inhibition, and this causes post synaptic inhibition. Presynaptic inhibition and post synaptic inhibition. Is this clear? Now you should know at least one example of both. Strychnine. Yesterday someone was asking about strychnine. Strychnine inhibit post synaptic inhibition. Post synaptic inhibition. Remember, strychnine is working different. Okay, titanospasmin is working differently. I will discuss all the three. Strychnine, all are doing the same action, but the mechanism is different. Strychnine inhibit post synaptic inhibition. Okay, by antagonizing action of glycine, in spinal cord, okay, and this is inhibited by picrotoxin. So picrotoxin work presynaptically, and strychnine inhibit postsynaptic inhibition by antagonizing action of glycine in the spinal cord. These are bit sensitive topics, so you should not make different. You should not be confused which is presynaptic, which is postsynaptic inhibition. So yes, you can comment in the chat box. Is this okay or not? Okay. Is this okay? Now, what about RENSA? Which is example of RENSA cell inhibition? If this is your motor neuron, supplying your muscle, this is your motor. These all are type of poison which cause disturbance in your neuromuscular junction and causes different types of sustained contraction, or it can cause tetanus. But there was a question that strychnine, it is also a poison. Picrotoxin is also a poison. So it work where? So it work post-synaptically. Inhibition is post-synaptic, and picrotoxin inhibit pre-synaptic. And Rensa cell. Rensa cell. What about Rensa cell? Rensa cell inhibit motor neuron. Yesterday we discussed Rensa cell is in the spinal cord. Yes, yes, Bhanu. Rensa cell is causing inhibition of motor neuron, and when there is tetanospasmin, when there is tetanospasmin, when there is tetanospasmin, it inhibit Rensa cell. It inhibit Rensa cell. So Clostridium tetani inhibit what? Negative feedback. It inhibit negative feedback mechanism. It inhibit negative feedback mechanism. So all three are different. All three are different. So if Rensa cell is causing negative feedback mechanism. Rensa cell is causing negative feedback mechanism. So if you inhibit it, this will keep on exciting. This will keep on exciting the muscle by repeated stimulus. It will give repeated stimuli, and this can cause tetanus. This can cause yes, it can cause action on the glycine GABA. So this is acting on the inhibitory neurotransmitter. It is acting on the inhibitory neurotransmitter. I will come to that point. There are two inhibitory, one is GABA, other is glycine, and one excitatory glutamate. So if time permits today, I will start today and continue tomorrow also. What are the excitatory transmitter, what are the inhibitory transmitter? Because questions nowadays are a lot of coming in AIIMS and the enhanced examination about these transmitter. That is why I am going into such detail. Now, neurotransmitter. Now, Bhanu is asking about neurotransmitter. So, neurotransmitter is of two types. I think today it is not finished, but tomorrow I will continue again. It can be excitatory. Which is the maximum neurotransmitter in your brain? Which neurotransmitter is maximum in your brain? This is inhibitory. Yes, Bhanu, which neurotransmitter is maximum in your CNS? It is glycine, it is GABA or glutamate, or whatever you think. Please comment. Glutamate, yes, 75%. 75% is glutamate. 75% is glutamate. And in inhibitory, it can be GABA or it can be glycine. So inhibitory are like this. Now tell me, glutamate have which receptor, metabotropic or inotropic? Glutamate has which receptor, metabotropic or inotropic? Glutamate has metabotropic or inotropic. Which type of receptor is in glutamate? Yes, both. Metabotropic as well as inotropic. Receptor. Metabotropic is called as metabotropic glutamate receptor. Do you know any example of metabotropic glutamate receptor? Yes, Anuj. Do you know any example of metabotropic receptor present in your? Yes, Bhanu, Anuj. Taste. Which taste? Which taste? Umami. Umami taste is because of metabotropic glutamate receptor. Inotropic are of three types. Inotropic are of three types. What are these? One is AMPA. Second is kainate. And third is NMDA. NMDA. There are three types of inotropic. One is AMPA, second is kainate, and third is NMDA receptor. Okay. Now, which causes influx of sodium and which causes influx of calcium? Sodium influx is by which one? Sodium influx is by which one and calcium influx is by which one? So you should remember this, that sodium influx is by mainly AMPA and kainate. These causes sodium influx. And NMDA causes calcium influx. And this is blocked by which ion? NMDA is blocked by which ion? NMDA is blocked by which ion? Who will tell me? Yes, it is blocked by, that is why in eclampsia and all those you use magnesium. It is blocked by magnesium ion. Okay. So should I revise this? Should I recap or should I discuss topic of glutamate? How glutamate act? What do you think? What do you want? I have 5 minutes, so either I can recap this or I can go to the glutamate topic. How glutamate act? Yes, Anush Kumar, continue. Okay, no problem. So, what is how glutamate act? I know loads of informations are there. It can take time. So please revise this video again and again. See, this is your presynaptic. This is your postsynaptic. This is your AMPA, and this is your NMDA. Which is activated first, AMPA or NMDA? Suppose this is your NMDA. Yes, Anuj, you want talking? Okay. But let me finish this, then tomorrow I will again recap it. NMDA, this is AMPA. This is your release of glutamate. This is release of gluta. At the end, I will revise talking again. First, there is release of glutamate. Now, glutamate will attach to AMPA or NMDA. Which first? Glutamate will attach to AMPA or NMDA. Who will tell me? Glutamate will attach to AMPA or NMDA. To whom it will attach? Yes, AMPA. It will attach AMPA, and this will cause influx of sodium ion. Sodium ion will generate action potential, that is EPSP. And you know NMDA is blocked by which ion? NMDA is blocked by which ion? Magnesium ion. NMDA is blocked by magnesium ion. So this EPSP will cause removal of magnesium. This EPSP will cause removal of magnesium. So when magnesium is removed, now glutamate can come and attach. But one thing more need to be attached here. What is that? One thing more need to be attached over here to activate your NMDA receptor. What is that? That is glycine. until glycine attached to NMDA receptor, NMDA receptor cannot be activated. So NMDA want glycine, NMDA want glutamate, both. And then only calcium can come. Then only calcium influx will occur. Is this clear or not? So first point, glutamate will attach to AMPA. AMPA will cause EPSP by influx of sodium ion. EPSP will cause removal of magnesium from NMDA. Removal of magnesium from NMDA. Now, magnesium is removed, but NMDA, there are three requirements. NMDA has three requirements. First is removal of magnesium, second is attachment of glutamate, and third is attachment of glycine. Now this will cause influx of calcium. This will cause influx of calcium, and this calcium can cause retrograde signal. This calcium can cause retrograde signaling by nitric oxide, and this will cause synaptic enhancement. This will cause synaptic enhancement, or this is also called as long term potentiation. It is also called as long term potentiation. You must be knowing about memory. Memory is because of long term potentiation or synaptic enhancement. Yes, attachment. Yes, Anush Kumar Baghel, attachment of glycine. See, there are three requirements: removal of magnesium blockage, attachment of glutamate, and attachment of glycine. Glycine is needed to activate NMDA. That is why glycine has dual role. Glycine has dual role. One role is inhibitory, other role is to excite NMDA. Okay, and calcium also attaches to CAM kinase. It also attaches to calmodulin dependent kinase. It also attaches to calmodulin dependent protein, kinase, and these cause various physiological events. So this is a very important point. You must remember. Let me summarize this diagram. See, point number one: when glutamate is released, it will not go to the NMDA receptor. First, it will activate AMPA. Before NMDA is stimulated, AMPA need to be stimulated by glutamate, and this glutamate, when activate AMPA, will cause influx of the sodium ion, and sodium ion will cause EPSP. EPSP of AMPA will cause removal of the magnesium blockade. It causes removal of the magnesium blockade. Number one. Number two, there need to be attachment of glutamate as well as glycine is needed to cause activation of NMDA. Now NMDA, when activated, cause influx of the calcium. This calcium cause two action. One is it can cause retrograde signaling by nitric oxide, cause synaptic enhancement, or we say long term potentiation, important for the memory formation. Or calcium can act as a secondary messenger attached with the CAM kinase, calmodulin dependent protein kinase, and it can cause so many physiological events like activation of AMPA, and there are so many physiological events. Is this clear? Is this clear to everyone? Please say yes or no, whatever in the comment section. If it is clear, then I can revise docking. So first is activation of AMPA. Second is removal of magnesium. Third is attachment of glutamate, and fourth is attachment of glycine. All those needed, then calcium will come, and then calcium will cause two action. Okay, Anuj Singh Baghel. Now Anuj want this diagram again. See, docking is just attachment of ship to the seashore. So there are so many chains. There are so many chains because when you deload the cargo, ship can go outward because of Newton's third law. So there should be so many chains. So there are mainly two protein. One is syntaxin of the nerve terminal, another is VAM or V snare, which cause docking. But there is one more protein. There is one more protein that senses the calcium, and that is synaptogramin. Synaptogramin senses the calcium. When voltage gated calcium channel opens, then calcium come outside. Then synaptogramin will sense the calcium and cause activation of syntaxin and VAM protein, and then it can cause release of neurotransmitter, or you can say docking phenomena occur. It can cause removal of neurotransmitter. As you all know, in NM junction, it attaches to the ligand gated and cause influx of sodium. So neuromuscular junction, this all you know. But because docking was important, that's why I took this topic also. That you should know there are two protein in the vesicle. One is VAM or V snare, other is synaptogramin. These are on the synaptic vesicle, and this is in the nerve terminal. In the nerve terminal, syntaxin. In the synaptic vesicle, V snare, VAM or synaptogramin. Among these two, which is calcium sensing? Calcium sensing is by synaptogramin, not by VAM. And one thing more, VAM needs activation of RAP3A by GTP. So this is the whole mechanism of docking. Is this clear to everyone? Docking phenomena and glutamate action. Yes, Anuj. Anuj Bagel, Raghu Verma. Yes, Dr. Chetan, Dr. Anuj, Dr. Bhanu. Is this clear? Okay, so tomorrow we will continue this topic and we will discuss about glutamate toxicity and the drugs which are acting on glutamate, and then glycine and GABA and all those things. Then other like serotonin. So whatever neurotransmitter are asked in your AIIMS and PGI examination, we will discuss very fast. So thanks a lot, Dr. Chetan, Dr. Anuj Bagel, Dr. Pawan, Dr. Raghu, Dr. Ravi, everyone, thanks a lot. And if you like this video, please like it, comment, share with your colleagues. So thanks for joining this session. Thank you, Dr. Raghu.